Welcome to the Explainer. So if you're here, you're a focused learner, right? You want to master the architecture of modern AI solutions, and let's be real, you are getting ready to absolutely crush the AI 102 exam. Today, we're taking a super structured approach. We're going to build what I like to call an enterprise blueprint. We'll literally step into the shoes of a lead architect and deconstruct a secure, end-to-end generative AI application right from the ground up. By the end of this explainer, you're going to have the conceptual clarity you need to confidently tackle those tricky scenario-based questions on the exam and totally avoid the common pitfalls that trip up so many candidates. Okay, let's dive into this. We're building our blueprint across 4 layers today. First, extracting content. Second, search and knowledge stores. Third, orchestrating agents. And finally, security and networking. Let's kick things off with layer 1, extracting content. This is all about turning messy, unstructured data into nice, clean schemas. Now, before an AI agent can answer any of your questions, it actually needs data it can understand, right? But enterprise data is, well, it's messy. It's locked away in PDFs, handwritten forms, audio logs, videos, the whole shebang. So our very first architectural challenge is extracting that raw content and parsing it into clean, structured schemas. And Azure gives us 2 distinct services to handle this. Think of Azure Document Intelligence as your precision specialist. It uses highly optimized, pre-built, and custom models to pull key value pairs, tables, and text specifically from documents, things like PDFs and images of invoices or receipts. It absolutely thrives on rigid, structured templates where consistency and low latency are the main priority. On the flip side, we have Azure Content Understanding. This is your generative AI orchestrator. It's fully multimodal. It doesn't just read documents. It can ingest audio files, video files, and images all at the same time, using large language models to actually infer meaning and generate structured schema extractions from incredibly complex, unstructured inputs. So, for the exam, if they ask you for video or audio summarization alongside documents, you definitely want content understanding. But if it's pure high-volume form extraction, document intelligence is for sure your answer. Sticking with document intelligence for just a second, let's look at a classic exam gotcha when it comes to custom models. When you're building a custom extraction model, you have to choose between a template model and a neural model, and this distinction is absolutely crucial. Template models are designed for fixed, rigid layouts. If your company uses the exact same form every single time, you use a template. It only requires a minimum of 5 documents to train, and the training is practically instant. Super fast. But if your documents have variable designs, like contracts or maybe different vendor invoices, you're going to need a neural model. Neural models require significantly more compute power to understand that variable layout, meaning training will actually take 1 to 2 hours. Keep those specific requirements in the back of your mind. They love testing you on when to choose neural over template and those specific training time differences. Moving right along to section 2, search and knowledge stores. Let's talk about indexing the enterprise. Okay, so now that we've extracted our data, we really need to map out the strict pipeline of Azure AI Search so our AI agents can actually retrieve it. You always start with a data source, like blob storage. Then the indexer acts as the engine, pulling data from that source. Now, here's the absolutely crucial part for the exam, so listen up. If you're using AI to enrich your data, say extracting key phrases or using NLP to detect and redact PII categories, you create what's called a skill set. And the skill set attaches directly to the indexer, not the index itself. I'll say that again. It attaches to the indexer. The indexer executes the skill set, creates the enriched data, and then uses output field mappings to basically bridge that new data into the final search index. Just remember that connection. Skill set attaches to indexer. But what if you want to use all that amazing AI-enriched data outside of Azure AI Search? Like, what if your data science team wants to run Databricks on it, or the business folks want a Power BI dashboard? Well, that is exactly what a knowledge store is for. You configure a knowledge store using projections directly within your skill set. It independently saves your enriched data structures as tables, JSON objects, or files straight into Azure Storage. It effectively isolates the enriched data from the search index, persisting it for all those downstream enterprise applications. It's just a brilliant architectural pattern to really maximize the return on your AI processing. All right, section 3, orchestrating agents. It's time to build the Foundry. So, with our data beautifully extracted, enriched, and indexed, we're finally ready to build an autonomous agent to actually interact with it. The AI 102 exam really wants to know that you can reuse existing resources without, rebuilding the whole thing from scratch.
So here is the exact step-by-step sequence required to deploy an agent and connect it to an existing vector-enabled Azure AI Search Index. First, you obtain the connection ID for your search resource right from your Foundry project. Second, you configure the Azure AI Search tool, specifying that connection ID, the index name, and the query type, like vector or hybrid. Third, you create the agent itself, passing in that configured tool. And finally, you validate the integration by starting a thread and asking questions grounded in your data. It's a really clean, efficient 4-step orchestration. While we're on the topic of orchestrating models, let's highlight a very specific and honestly very common exam pitfall regarding Azure OpenAI REST API calls. If you're building an application that makes direct HTTP requests to generate images with DALL-E 3, there are 3 mandatory HTTP header properties you absolutely must include. You need the API version used in the operation, the name of the Azure OpenAI service resource, and the name of the DALL-E 3 model deployment. Do not confuse these with the HTTP body parameters like the prompt itself or the image size. Furthermore, remember that your authorization key doesn't just go anywhere. It has to be passed using the specific header name OCP APM subscription key. Just getting these exact header names correct is easy points on the exam, for sure.
Okay, so we've built this incredible application. We have multimodal extraction, vector search, and a Foundry agent seamlessly answering questions and generating images. But as an enterprise architect, this is where you really need to pause. Because a powerful agent connected to your enterprise data is also a highly valuable target. So how on earth do we keep this autonomous agent from being hijacked?
That brings us to Section 4, Security and Networking, defending our blueprint. We have to defend our blueprint by locking down the application at the content layer. As generative AI evolves, unfortunately, so do the attacks against it. First up, we have user prompt attacks, which are often called direct jailbreaks. This is when a user directly types something into the prompt window to try and bypass system rules, like telling the bot to, ignore previous instructions and act as developer mode. But actually, the more insidious threat is the document attack, or indirect prompt injection. This happens when hidden, malicious instructions are secretly embedded inside a third-party document or maybe an email that your agent processes. When the agent reads the document, it inadvertently executes those hidden instructions, completely hijacking the session. This is exactly why you absolutely must configure Azure AI Content Safety prompt shields to scan both user inputs and tool responses. Now, the crucial point here is how this all integrates with your broader security posture. Microsoft Defender for Cloud offers AI threat protection, but it relies heavily on those Azure AI Content Safety prompt shields we just talked about. If someone tries a jailbreak attack, prompt shields will block it. However, a really common troubleshooting scenario they'll throw at you on the exam involves the developer seeing a prompt blocked in the Foundry Playground, but not seeing an alert in Defender for Cloud. And you might wonder, why? Well, because Defender alerts are generated based on specific prompt shield signals combined with Microsoft Threat Intelligence. You're looking for a very specific alert family name, like ai.azure_jailbreak.contentfiltering.blockAttempt. You have to ensure your threat protection pipeline is fully integrated to actually surface these critical security events. Finally, we've got to lock down the network with Azure Private Endpoints to ensure our traffic stays safely on the Microsoft backbone. But to make private endpoints work, your virtual network needs to resolve the DNS correctly. And you really need to notice the subtle DNS differences here. Azure AI Search uses privatelink.search.windows.net. Azure OpenAI has its own dedicated zone, privatelink.openai.azure.com. But services like Vision, Language, and Face API, they share the broader privatelink.cognitiveservices.azure.com. Oh, and as a quick aside for the Face API, always ensure you're specifying the Detection O3 model, as it's the current standard for high accuracy on the exam. Do not mix up these domains. It is a classic trap they use to test your networking precision, so keep them straight. Wow, okay, we've covered a massive amount of ground today, from extracting multimodal content and indexing it with skill sets to deploying agents and locking them down with prompt shields and private DNS zones. But as we wrap up this explainer, I want to leave you with a bit of an architectural reality check. You can have the absolute best prompt shields in the world, but security is never absolute. So ask yourself, if a sophisticated, indirect document attack somehow slips through your content filters, is your network architecture locked down enough with private endpoints and managed identities to contain the blast radius? Keep that defense in depth mindset front and center, and you'll not only ace the AI 102 exam, but you'll build AI solutions your enterprise can actually trust. Thanks so much for learning with me today.